Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this yet another video of the chapter Fats and Oils. In this video, we are going to discuss about the physical and chemical properties of fats and oils. In previous videos, we have covered the classification of the lipids. We have finished with the simple lipids. Also, we have seen compound lipids. If you are coming first time to this my YouTube channel, you can watch the previous videos, and to get the more videos related to the pharmaceutical organic chemistry, you can subscribe to my YouTube channel. If you like the content of this video, you can share with your friends. So let's begin with our today's session. Before that, just we will see what are the learning outcomes of this session. After this session, students will be able to explain physical and chemical properties of fats and oils. So let's begin with different physical as well as chemical properties that are shown by fats and oils. First, we will discuss what are the different physical properties that are shown by fats and oils. First physical property is fats and oils are lighter than water, hence they form upper layer when they are mixed with water. Means they will be saturated on the upper layer as compared to the water because they are having the denser as compared to the water, or they are lighter as compared to the water. That's why they will form the upper layer. They are the bad conductors of heat and electricity, due to which the loss of body heat is not done due to the presence of lipids that are present inside the skin. They are non-volatile at room temperature. They are readily soluble in non-polar organic solvents, but they are insoluble into the water. All the fats and oils are insoluble into water, but they are readily soluble in non-polar organic solvents. Natural fats and oils are colorless, odorless and tasteless solids and liquids in pure state at the room temperature. Only natural fats and oils are colorless, odorless and tasteless. So these are the various physical properties that are shown by the fats and oils. Now, after completion of physical properties, next point that we are going to discuss is chemical properties of fats and oils. Now, chemically, as we know, fats and oils are considered as a glycerides, which are nothing but the esters. That's why they exhibit the similar behavior as that of the simple esters. Now, following are the some important chemical reactions that are shown by the fats and oils. We have studied the chemical reactions of the esters. Few of the simple esters shows various types of the reactions. Same reactions are shown by these fats and oils because they are nothing but the glycerides, and glycerides are nothing but they are the esters of free fatty acid with the glycerol. Now, first reaction that is shown by fats and oils is hydrolysis. Hydrolysis of fats and oils is carried out in presence of mineral acids or the steam or the enzymes to form the mixture of free fatty acids and the glycerol. Because we know that these fats and oils are made up of the free fatty acids as well as the glycerol, due to which what happens when they are hydrolyzed, they will be converted into the mixture of free fatty acid and the glycerol. Also, free fatty acids that are generated, they may be same or it may be different. It depends upon the which type of fat or oil is hydrolyzed, because glycerol is connected to the 3 fatty acids in the fats and oils. Lipase is an enzyme which also brings about the hydrolysis of fats, but this hydrolysis is carried out in stepwise manner. Means first triglycerides are converted into the diglycerides, means only one ester functional group that is present in the fat and oil that will be hydrolyzed, so that triglycerides are converted into the diglycerides. Further, diglycerides further undergo the hydrolysis with the lipids to get converted into the monoglycerides, and monoglycerides are finally, when undergo the hydrolysis, they will be converted into the glycerol and fatty acid. In this way, in stepwise manner, there will be formation of the glycerol and fatty acid takes place when the reaction is carried out by using enzymatic hydrolysis with the help of the lipase enzyme. Now we will see actual reaction. Here you can see this is the example of the triglyceride, where you can see 3 ester functional groups that are present here over. So if we carry out the hydrolysis in presence of either alkali or acid, directly there will be formation of this glycerol molecule. Here you can see there is a presence of 3 hydroxyl groups in the structure of the glycerol. In addition to that, there will be formation of free fatty acid molecules will takes place. Also, if we carry out the hydrolysis with the help of the enzyme lipase, what happens? First, this ester functional group or one of the ester functional group from these 3 will be hydrolyzed, and this triglyceride will be converted into the diglyceride. Now you can understand why this is known as the triglyceride, because there is a presence of a glycerol molecule with the 3 fatty acids. That's why it is known as the triglyceride. In second step, further enzyme lipase will carry out the hydrolysis of second ester functional group, which leads into the formation of monoglyceride, and this monoglyceride further undergo the enzymatic hydrolysis to form the finally the glycerol and the fatty acids. In this way, fats and oils show first chemical property as hydrolysis. Second most important property that is shown by the fats and oils is saponification. Now, what is the meaning of saponification? When the fats are hydrolyzed with the help of the alkali, they forms the free fatty acids. When these free fatty acids react with alkali to form the salts, these salts are known as the soaps, and the process is known as the saponification. This saponification process is also known as alkaline hydrolysis of triglycerides, which gives us a glycerol and mixture of salt of long chain carboxylic acids. These salts are nothing but the either sodium or potassium salt, because here in case of saponification we are going to carry out the hydrolysis in the form or in presence of alkali, because in previous reaction we have seen hydrolysis in which there are multiple ways are there by which we can carry out the hydrolysis. One of the way was the alkali hydrolysis. So if this hydrolysis is carried out in presence of alkali, they forms the free fatty acids, and as these free fatty acids are capable of reacting with the alkali, further they will react with the alkalis and they form the sodium salt of this free fatty acid or the potassium salt of this free fatty acid, and these salts are nothing but the soap, and this process is known as the saponification. Now we will see the reaction also. These salts of long chain carboxylic acids are soaps, and the reaction is known as the saponification. Here you can see this particular reaction. As you can see, this is the structure of triglyceride. It may be oil or fat. Here you can see 3 different free fatty acids are present, which is consisting of alkyl group as R, R dash and R2 dash. When hydrolysis is carried out in presence of sodium hydroxide, it leads into the formation of glycerin, which is nothing but the glycerol, and the 3 free fatty acids that are to be generated along with the sodium salt. Now, because in this reaction sodium hydroxide that is used, it is used in excess amount, so that what happens, first in presence of sodium hydroxide, this triglyceride will be hydrolyzed, it will be hydrolyzed into glycerol and the free fatty acid. These free fatty acids that are generated, they are reacted with the sodium hydroxide, so that there will be formation of sodium salt of free fatty acid will takes place, and this sodium salt of free fatty acid is known as the soap, and the process is known as the saponification. So this can be defined as the number of milligrams of KOH required to neutralize the free fatty acids that are generated from the 1 gram of oil or fat sample. So this is the definition for saponification. In detail we are going to see how saponification is determined. Also we are going to see the difference between the different oil constant values that are used to define the fats and oils. Now, by correlation, any reaction of an ester with an alkali to form the alcohol and the salts of an acid is commonly referred as the saponification reaction, because triglycerides are nothing but the esters. So esters, when undergo the hydrolysis, first they will be converted into the alcohol and carboxylic acids. Further, these carboxylic acids will react with the alkali, which leads into formation of the salt. So that's why these common reactions are known as the saponification reaction. Now, soaps are composed of molecules that contain large hydrocarbon groups, the lipophilic, that is the fat loving group, and the polar groups, which are known as the hydrophilic groups. The lipophilic portion, which is sometimes referred as a hydrophobic, that is the water faring groups, dissolves in grease or oils, and the polar portions are soluble into the water. That's why soap molecules, when dissolved in water, they aggregate to form a less ordered structure, which is known as the micelle. Micelle is nothing but the spherical structure that is present, in which all the molecules of soap, they are ordered in such a way that the hydrophobic portions will be present outside and the hydrophilic portions will be present inside. Micelle is a roughly spherical assembly of large molecules that have both polar as well as the non-polar regions. So, because soaps are they are composed of molecules that contain the large hydrocarbon groups, which are known as the lipophilic groups, and also they are consist of the hydrophilic groups also. And due to the presence of both the water loving and the fat loving groups that are present, they will form a less ordered structure, which is known as the micelle. The fatty region of the micelle can absorb other non-polar fatty substances and carry them hidden into the water solution. That's why soaps are generally used to carry out the removal of oily and the grease from the fabric, because whatever these hydrophobic portions are there, they will be absorbed in the micellar form and they will carry out them hidden into the water solution. Now, typically, whatever these groups are present, they are having these types of the structure. Here you can see this is nothing but the structure of the soap, where you can see this is the sodium, this is carboxylic acid group. So you can see the carboxylic acid group is present, sodium salt of the free fatty acid. So here you can see there is a presence of long chain is present, and that long chain is corresponding to the hydrophobic tail. And here, due to the presence of this carboxylic acid group with the help of the salt, this is known as the hydrophilic head. And when so many number of molecules come together, they will form this type of the spherical structure, in which the hydrophilic portion is present inside and the whatever the hydrophilic is inside and hydrophobic portion forms at the outside. So this is about the saponification value. So in this video we have covered two chemical properties, remaining properties we will cover in the next video. Thank you.